Hi guys, welcome back to Math with James. So last time we talked about power functions. Fx is equal to x raised to the power of a. Then we talked about two different situations. A is equal to n, where n is a positive integer, and a is equal to n to 1 over n, where n is the positive integer. For the first one, usually you can divide it into two different types of functions, the even functions, like fx is equal to x squared, all these even numbers for the exponents. But when n is an odd number, the function becomes an odd function, like fx is equal to x raised to the third power, or the fifth and seventh, and so on. For the second situation, then basically you get the square root, the cube root, the fourth root of x as a function, and each of them have a different graph. Today we're going to see the third situation. So 1, 2, 3, where a is -1. So basically fx becomes x raised to the power of -1. And according to the law of calculation of exponents, this is equal to 1 over x raised to the power of 1. I'm not going to write 1 anymore. And the graph of this function basically looks like this. For all of the x's greater than 0, the bigger the x is, the smaller the value of this thing is, right? So, and the smaller the value of x is, the whole value of 1 over x is going to be greater and greater. So we can basically draw the graph out like this. You can also basically say that the graph rises to infinity when x approaches 0, but x can never be 0, because when x is 0 for the denominator, it's not, this function is not defined anymore. And what about the negative values for x? The smaller the value of x is for the negative domain, the smaller of the whole value of this thing is. So basically the graph goes this way. It will never touch, the graph will approach the y-axis infinitely, but it will never touch it because x can never be 0 in this case. And we can say that when x approaches 0 from the left side, then the value of the function approaches -infinity. And this function is really useful when it comes to chemistry and physics. So that's a topic that we have discussed before. Like all these bizarre functions, you might say, actually have their tremendous functions in real world. Almost everything that is around you has something to do with the functions that has been studied by scientists and mathematicians for generations. The basic usage of this function in physics is a function called the Boyle's law. Boyle's law states that in a container which has the constant temperature holding a certain amount of gas, the pressure of the gas has this relationship with its volume. So volume V is equal to C over the pressure. So C is a constant number. So the bigger the volume of the gas is, the smaller the pressure is, vice versa. And this is pretty useful when it comes to like the engine in your car and things alike. So that's all for today. Take care. I'll see you guys next time.